All right, so we're going to go over example 4. There's 3 parts to this, and you'll notice that there's 3 different classifications: contradiction, conditional equation, or an identity. So let's look at 3 different examples. You're going to have to work through an equation to be able to determine which classification it fits under. So in this slide, we define each of the possible classifications. And you'll notice that identity, it says an equation that is true for all values. In the textbook, they're a little more specific but they say which all terms of the equation are defined. And we'll notice that with linear equations that we're dealing with in this section, that the all terms of the equation are defined doesn't really apply. So I left that off. We will address that later if it comes up. But for linear equations, it's an equation that is true for all values, and that's what an identity is. So, anyways, I won't go into too much more detail about that, but let's just go into the first example, and we have x plus 1 equals x plus 4. And so we want to solve this. And I'm going to go through solving because we've already dealt with that with the previous 2 examples. So we use the addition, subtraction, multiplication, and division property of equality, and simplifying, which will only really apply to C in terms of simplifying at first. Each side of the equation before you use those 2 equality properties. So part A, let's look at that first. So we have x plus 1 equals x plus 4. We're going to subtract x from the left and right side of the equation, and that will actually cancel on both sides, which is interesting. And then we're going to subtract 1 from both sides of the equation to eliminate the constant on the left side of the equation. And we're left with 0 equals 3. 0 equals 3. And we'll notice that that's not true. 0 does not equal 3. And so we call this a contradiction, because an equation that has no solution, there's no way that 0 can equal 3. If you end up getting a false equation at the very end after solving, then that is a contradiction. 0 will never equal 3, so there's no solution to x plus 1 equals x plus 4. So this is a contradiction. Okay, so we've identified that it's a contradiction, and again, that means no solution. Okay, so on to B. We have 4x plus 3 equals x minus 9. And again, a vertical line might help. All right, and so we want to get the variable term on the left side of the equation. So we have to eliminate this right here. And then we want to get the constant on the right side. So we'll subtract 3 and eliminates that. And we're left with 4x minus x is 3x. And a negative 9 minus 3 is negative 12. And now we want to divide by 3 to eliminate the coefficient. And we get x equals negative 12 divided by 3 is negative 4. So this is, by definition, a conditional statement. A conditional statement, as mentioned in the slide, is an equation that is true for some values, but not all values. So it's equal to negative 4. So this is a conditional equation. Okay, because it's equal to just one solution. It's not none, and it's not all solutions, so it's conditional. All right, and let's move on to the third equation here. All right, so we have 5 times 3x minus 2 x minus 4 equals, and this is C, 8x plus 18. So as we can see here, we actually need to simplify both sides. Both sides of the equation are not simplified. As we can see, the right side of the equation is simplified. So really, we just need to work on the left side right now and get it simplified. So we need to use the distributive property, and we'll get 15x 5 times negative 2 is negative 10, and then we also need to distribute again with negative 7, and then we have negative 7x, and negative 7 times negative 4 is plus 28, and we get 8x plus 18, bring that down, and then we're still simplifying the left side. We're not done yet. We have some like terms, and we are left with 8x negative 10 plus 28 is plus 18. That's equal to 8x plus 18. And actually, we can know it. We notice at this point that we have the same thing on the left and right side of the equation. So if we were to use, subtract 8x, and subtract 18, and subtract 18, you don't actually. We're actually done at this point. We're right here. We don't need to go any further from here. And we can actually tell that this is always going to be true. 8x plus 18 is always equal to 8x plus 18. But also, if you were to just continue on, if you didn't notice that you're done here, you'll notice that everything cancels out when we subtract. And then we get 0 equals 0. If you end up getting 0 equals 0, which is true, it's always true, then this is the identity property. Okay, and so, and you could also have stopped at like 18 equals 18, and as long as you notice that it's always true, that no matter what value you plug in for x, it will always, the left side of the equation will always equal to the right side of the equation at some point, then you know you have the identity property. And remember, identity property is an equation that is true for all values. When you're dealing with a linear equation, it's all values. So you'll notice that whatever value you plug in for x, you can plug in, pi or anything, 2.48 or anything in for x, you'll always get the same value on the left and right side of the equation. So all values will be the solution. So that's the identity. All right, so those are the 3 different classifications for an equation. You can either have a finite number of solutions, which is conditional equation. You can have no solution, which will give you a contradiction, or there's an infinite number of solution, which is identity. All right, let me know if you have any other concerns, and I'll be more than happy to help.